In the quiet vastness of the sky, high above the earth, two aircraft draw closer, one carrying fuel, the other running low. They're traveling at hundreds of kilometers per hour. The margin for error is razor thin. And then, like a mechanical handshake in the clouds, a boom connects to a nozzle, or a flexible hose latches onto a drogue, and fuel starts flowing from one aircraft to another, while both remain in motion. It seems almost impossible, like threading a needle in a hurricane. But it's real, and it happens every day. It's called aerial refueling, and it's one of the most awe-inspiring and precise operations in aviation. It extends the range of aircraft, keeps missions alive, and powers long-distance operations that would otherwise be impossible. But how exactly does it work? What are the mechanics behind it? And how did engineers solve the seemingly unsolvable problems that come with fueling a plane mid-air? To appreciate how daring aerial refueling is, imagine trying to pass a glass of water between two speeding cars on a windy highway with your hands tied. Now scale that up to tens of thousands of feet in the air with massive fuel hoses, unstable wind patterns, and a critical mission on the line. That's the challenge faced by the crews who conduct in-flight refueling. The idea isn't new. In fact, the first experiments with aerial refueling date back to the 1920s. Pilots would manually lower fuel hoses between aircraft, with co-pilots climbing out of cockpits to grab and connect them. It was crude, dangerous, and incredibly risky. But it proved a powerful concept. Refueling in the air could vastly extend flight time, military reach, and logistical power. Over time, aerial refueling evolved into a sophisticated science. Today, there are two primary methods: the probe and drogue system and the flying boom system. The probe and drogue system is used widely by NATO countries and naval aviation. It consists of a flexible hose extending from the tanker aircraft with a basket-like attachment called a drogue at the end. The receiving aircraft is equipped with a probe, which the pilot must guide precisely into the drogue. Once connected, fuel is pumped through the hose. The entire maneuver demands extraordinary skill. The receiving aircraft has to align and maintain position in turbulent air, with the hose swaying and flexing. The flying boom system, used predominantly by the U.S. Air Force, is more rigid and allows for faster fuel transfer. A telescoping tube called the boom extends from the tail of the tanker. It's controlled by a boom operator who lies prone at the rear of the tanker aircraft, using a combination of joysticks and precision sensors to guide the boom into a receptacle on the receiving plane. Once locked in, fuel flows rapidly, sometimes thousands of liters per minute. Both systems require remarkable cooperation between pilots, crews, and technology. Communication is critical. So is timing. The refueling window is often brief, sometimes just a few minutes. Weather conditions, aircraft load, fuel pressure, and turbulence all have to be constantly monitored. But why do we go to such lengths? The strategic value is immense. Fighter jets are fast, agile, and powerful, but not built for long range. Without refueling, their operational radius is limited. Aerial refueling turns short-range fighters into global assets. It allows bombers to reach distant targets, reconnaissance planes to loiter over mission areas, and cargo aircraft to bypass land-based fueling stops. During military operations, aerial refueling is a force multiplier. It allows aircraft to remain airborne for hours, or even days, without touching down. In humanitarian missions, it enables faster response over vast, remote regions. In scientific research, high-altitude aircraft can stay aloft longer to gather data on weather, climate, or atmospheric conditions. And aerial refueling isn't just for planes. Some drones, such as the MQ-25 Stingray, are being developed to conduct and receive mid-air refueling autonomously. This pushes the limits of automation and artificial intelligence in aviation. Imagine drones refueling each other mid-flight in coordinated swarms without human intervention. Of course, none of this is easy. Let's look at the fuel itself. Jet fuel is dense, flammable, and heavy. Transferring it in freezing temperatures at high altitudes means managing pressure differences, preventing icing, and ensuring seals don't fail. Aerial refueling systems must be rugged yet flexible. Redundant valves, pressure regulators, and emergency shutoff mechanisms are all built in. Then there's the aerodynamics. As two aircraft fly in close formation, their wakes, turbulent airflows trailing from wings and engines, interact. This turbulence can buffet the receiving aircraft, making it harder to maintain position. Pilots must be trained to compensate, using fine adjustments in throttle, pitch, and yaw. One wrong move and the boom can miss its target. or worse, strike the fuselage. To mitigate these dangers, simulators are used to train crews in exact conditions. These aren't video game-style training tools. They're fully immersive environments with motion platforms, real cockpit instrumentation, and even haptic feedback to simulate turbulence and hose tension. Hours of simulation precede any real-life refueling mission, and technology continues to evolve. Modern tankers like the KC-46 Pegasus come with advanced avionics, touchscreen controls, 3D visualization for boom operators, and automatic alignment systems. In the future, we may see fully autonomous refueling drones controlled by AI, mid-air fuel distribution hubs, and adaptive fueling pods that adjust to different aircraft types on the fly. The logistics are also fascinating. Tanker. Aircraft are mobile gas stations in the sky, strategically stationed at key points during missions. Coordinators plan routes, timing, and fuel loads to ensure that aircraft receive just the right amount of fuel at just the right time, without overburdening the tanker. It's an aerial ballet choreographed to the second. The level of detail is staggering. A single refueling mission can involve calculations for wind drift, aircraft speed differential, load balancing, altitude density, and fuel expansion due to temperature. Even the act of connecting a boom or probe must take into account flex, lag, and delay between visual alignment and contact. But the result is transformative. In 1949, a U.S. Air Force B-50 Superfortress named Lucky Lady II became the first plane to fly around the world non-stop thanks to in-flight refueling. It was a turning point, a proof of concept that gave rise to the global reach of modern air forces. Since then, mid-air refueling has enabled strike missions across continents, 24-hour air patrols during crises, and unbroken surveillance over conflict zones. It's also an expression of sheer human ingenuity. We've taken a task that was once unthinkable, moving tons of volatile liquid between two moving machines in the sky, and turned it into a routine procedure. Each time it happens, it's a moment of trust, precision, and technological marvel. It shows what happens when engineering pushes past perceived limits. As we look to the future, space travel, hypersonic jets, global drone fleets, the lessons of aerial refueling will continue to apply. How do we sustain motion in environments where stopping isn't an option? How do we build systems that are flexible, adaptable, and resilient under pressure? Aerial refueling answers those questions every day. And now, when you see footage of two jets linking high above the Earth, or hear about a mission spanning thousands of kilometers without a single landing, you'll know the hidden science, engineering, and courage behind it. Thanks for flying with us through this incredible story. If you found this video fascinating, drop a like, share it with a fellow aviation enthusiast, and don't forget to subscribe to the channel. We've got more deep dives into the secret systems that keep our world moving, and we'd love to have you along for the ride. Until next time, keep your curiosity fueled, and always aim higher.